Hey everybody, welcome to the EOF Implementers Call number 27. I think we talked about EOF on All Court Devs a couple of weeks ago for the first time in a while and had a pretty good conversation about it there. And yeah, I'm curious what people have been up to in the last couple of weeks on the client side. Does anybody have an update they wanted to share? Not everybody all at once, please. Hyman?
Hello, can you hear me by the way?
Yes.
Okay. In Nethermind, we are re-implementing EOF because it's been stale our branch has been stale for a while right now, and trying to catch up quickly with the mega stack. And that's what we're doing right now.
Cool. Anything on EVM1?
I don't think we have much. Many people are off these days. We are still have several implementations in progress of the changes to the spec that were discussed in the last calls. So like disallowing unreachable sections is one, and like new design for grade 3 and 4 is still also in progress, and also making grade 4 address unit codes by hashes instead of indexes. So these are the changes we're working on, but still in progress.
Sounds good. Dano, anything on Basis side for updates?
No, I've mostly been writing presentations and doing video advocacy to try and get EOF to happen. So one question I was looking into possibly doing jump FI and call FI. Just had some questions like what are the opcode numbers going to be for these proposed operations? So that can be discussed later on. It's my update.
Thanks, Dano. I guess that's probably all of the client updates. Let's go through anything on the compiler side and then we can jump into some spec discussion. I see we've got Daniel here. Any updates from Solidity on EOF?
Not really. Yeah, I mean, we've had the implementation of the previous version last year, but since then, I'm a bit skeptical about the guarantees that all quarters can make for it ever happening, was a bit hesitant to spend time re-implementing the new version. We may do that, but yeah, I'm still catching up with the changes. We've discussed internally with Ypsilon a lot of the changes, but yeah, from our side, we haven't yet updated our implementation to the latest version.
Thanks for that update, Daniel. Charles, anything to share on Viper side?
No, about the same.
Okay. All the updates are done then. Shall we jump into spec discussion? I don't think I saw anything specific on the agenda. What do you guys have on your dockets?
Yeah, I think we discussed it in the channel, but maybe it never made it into the agenda point. I think there was basically 2 points we really wanted to discuss, especially that we have both Daniel and Charles on the call. So the 2 questions regarding language implementations, and one of them is the various versions of the swap dupe, so EIP 663. The other point was the stack validation or AirJump IF. And I think lastly, it's just really the call to size or versus gas regressions. I think these are the 3 topics of which we really need to make a decision on. Probably I would suggest to start with the stack validation because Andrei wrote up a a lengthy explainer of the topic. And we did share it with Daniel. I believe, Charles, you also read it. So maybe that's like a good one to start with. I'm not sure, Andre, do you want to lead the discussion since you wrote the document?
Sure, I can give an intro. It was written by Pavel partially to actually the introduction part, and so in 2 words, there is a problem with the current stack validation, which makes things difficult for compilers, or like leads to code size regressions where they want to jump into helpers from different stack heights, and current stack height validation restricts this to any instruction in the code to be reachable only from the same stack height. And so we've thought about one algorithm that loosens this restriction, but makes it, the algorithm itself becomes a bit more difficult or complicated, and there's also an extra requirement for how the code blocks are ordered in the code section. Specifically, any block is reachable via a forward jump or just a flow of instructions. So it means that no blocks are reachable only via a backward jump. And in this way, we can go over all instructions in one pass, linear pass, instead of using a work list, and then keep track of like the range of stack heights for each instruction, and in the end, like allow a range instead of one specific stack height for each instruction. And this seems to solve the problem, but like makes it more complicated. And another solution, which is not really a solution to the problem, but rather an approach that compilers would take instead of using functions or code sections for these helpers, but just use, or rather, no, this first approach was actually when they don't use code sections for helpers, but use just regular relative jumps. And if they put the helpers into the functions, then Jumpify might be the solution that like leads to a better code size in the end and makes it acceptable to put these helpers into separate functions. So to me, it seems that like, yeah, on the one side, this more complicated algorithm is more complexity, but then the question that we have also, if it's possible then to drop non-returning functions from the spec and jump F, maybe they are not needed, and then everything will be using just these jumps, and helpers will be just like blocks inside the same code section. Then maybe in the end the entire spec will be simpler even. That would be nice, I think. And yeah, so
one difference is that Jumpify has some other good properties, which it allows better code sharing. So you can always factor out some shared code into a subroutine. Whereas if two subroutines have the same code, merely relaxing the stack validation rules won't help you outline that code.
I mean, it's two separate things, really. It's code deduplication within functions and across functions. I mean, the stack validation relaxation allows code deduplication within one function, and the jump FI approach makes it easier to do a cross-function code deduplication. The disadvantage is that you need to have header sections for the functions that you outline. That's the main thing where the stack validation relaxation has the advantage. If you don't want to deduplicate across functions, you save the overhead of the function headers. Right.
Right. Yeah.
So ideally, we'd have both.
Right. Ideally, we would have both. But I'm saying that the deduplication across functions is like more general, because you can always deduplicate across functions even at the cost of a function header and call. But if you only have the stack validation relaxation, then you might be in some situations where you can deduplicate code within a subroutine, but not across subroutines.
Yeah. The actual code size trade-off would be easier to evaluate if we had complete implementations of all the options, of course, but it's significant effort.
The code size issue has also helped a little bit. It's helped a little bit if there's R jump and I. So a lot of instruction sets have jump if 0 and jump if not 0. So if EVM had both of those instructions, then we could save a bunch of is zeros, which doesn't entirely fix the problem, but it makes it more palatable. And it's also really easy.
That's getting a lot of jump up codes then.
Right.
I
So
mean,
we
in
could
general,
choose...
in our... Sorry, go ahead.
Yeah, so we could like choose between them, or yeah, like you said, we would need a complete implementation to like really compare all of them. But yeah.
The last implementation that we had of the previous version, I mean, all of this applies to the previous version as well, basically, indicated that actually the dropping of jump tests already decreased code size costs a lot. So yeah, it's the code size increase I was initially more worried about than after I had this initial implementation, although that implementation was written against a incomplete EVM1 implementation that allowed jumping to blocks from different stack sizes and had code deprecation in it. So even though only within functions. So that had actually some code size improvement in the end. But yeah, it's...
Yeah, for Viper, actually, even with the jump test removal, we got a code size regression.
Interesting. I mean, the main question is, and I mean, from the compiler side, I think it's rather clear that we ideally want to have all of this. The question is, what's the maximal option out of this that we get or can realistically expect? So what kind of choices can we have between combinations of what we just discussed? That's basically what we need to do, I would say.
Yeah, we're trying to minimize the overall complexity, and I would say we should have either one of them. And I should note also that both of them are forwards compatible, so we could theoretically introduce another one as a later upgrade. And I don't know, given that if jump F and non-return functions are useful by themselves and we can't get rid of them with relaxed stack validation, then maybe Jumpify is a simpler one to add, and this is just, yeah. So the options, I would say, to having in mind the goal of minimizing the complexity is less restricted stack validation, but no non-returning functions and no jump path, or restricted stack validation and jump path and non-returning functions and Jumpify. That's, I think, how I see it.
I think I'm okay with Jumpify. I think it's like a general solution, and it seems to me that the implementation is simplest for the clients. I have a concern that it's a little bit more expensive than our Jumpy, and that might add up.
The problem is it makes it more complicated for us to determine when sharing the code is actually cheaper, because you always have to account for the additional overhead. The code duplication using RJumpI within the single function is always beneficial, so that's a no-brainer. But it's not like that's, yeah, a blocker.
Yeah, it produces a code size versus gas kind of trade-off, which you have to take.
I would say I'd really like to have the ability to deduplicate within functions, but I would tentatively be fine with JumpFI as well. Even though it's from our side, I think the more complicated solution. I mean, one more thing to consider maybe is, I mean, one can simulate JumpFI with RJumpI and JumpF, of course. That makes it a bit more expensive then, and is reliant on having the stack height relaxation, because you would jump, these RJumps would jump from different stack heights. But that, not sure whether there's a good measurement of how much an improvement JumpFI would actually be on top of that if one has code duplication within functions. Without having code duplication within functions, that sucks. But I mean, with that, not entirely sure.
Yeah. So one use case I realized for JumpFI is that you can actually perform stack unwinding, because you can have like a help. You can kind of like emulate retFI, which you can also do with RJumps, RJumpI. But it's kind of interesting because you can have like a shared stack unwinding routine. So it gives you different ways of terminating execution of the subroutine.
I mean, sharing that between multiple subroutines.
Yeah.
I mean, but why does it need to be conditional? I mean, you can still do that with an RJumpI and a JumpF. I mean, it's just minor optimization there of that becoming a bit cheaper. I mean, that only works if we have the stack height relaxation, because all these cases where you share stuff like that, I mean, stack unwinding maybe not, but a lot of cases are from different stack heights. So, I mean, I'm a bit worried that the strict stack validation will bite us in the back in the end, because
yeah, it's very kind of, yeah, it's restrictive. And I see what the want for it from the bytecode analysis side, but it does make the compiler's job like a lot harder.
Maybe there's like one reason for it, is that if we are unsure, what is the good version, if you do start with a much more restricted version, then it can always be relaxed. But going the other way around is going to be way harder, if not impossible.
But I don't think that there's really any reason to go from the relaxed validation rules to more stricter validation rules. Like, I don't think there's any benefit to analysis. The only con is like it's a more complicated algorithm. But there's no like semantics reason that I see that we would ever want to get more restrictive on the stack validation.
It's true. Could even imagine that it's eventually maybe with a different algorithm even possible to get around the ordering requirement. Haven't planned to think through that, but never got around to. But
Do you mean the forwards versus backwards requirement?
yeah.
Yeah, I agree. I suspect that it can be completely relaxed, but I don't. Yeah, so I haven't gotten around to thinking through it.
But yeah, I mean, the restriction is something we can deal with in the compiler. That's not too much of a hassle, I think.
You mean the ordering restriction?
Yeah.
Yeah, it's fine. The ordering restriction basically says that you can't have like these unbounded loops, which from the compiler perspective is totally fine.
But yeah, that kind of didn't bring us further now.
Well, it did because like you said, you can so in this document where we go through JumpFI, it doesn't at the very end of the document there's no should I share my screen?
Yep.
Hello?
Yeah.
Yeah. So it this is with current EOF, this is with JumpFI, but there's no example of what it would be like with relaxed stack validation, and what that would look like is I don't know if I can leave a comment or how do I leave a comment? It would basically look like push condition or jump by code then at end of the subroutine at end of subroutine code.
And there you have the
But, yeah.
choice whether it occurs in multiple functions and to jump F in the helper code, or
Right,
if it only occurs in one function to just inline it there. I think that's
Or-
actually nice. And I'm not sure whether the jump FI really improves that much across that.
Right.
I mean,
And
the
jump
additional.
Sorry,
Go ahead. Okay, I mean, the additional code size involved in that pattern is probably, I mean, yeah, maybe even alleviated by being able to inline some of the helpers if they're not used across functions.
Yes, you can take the choice whether to inline the helper or jump F out. But it's obvious here that the gas performance is best.
What do you mean that jump FI is cheaper?
Sorry, it's best in the happy path.
Yeah.
And usually these kinds of things are used with something that's very likely or unlikely, so you can kind of optimize around that.
Yeah, but I mean, this discussion now so far leaves me to conclude that actually the stack height validation relaxation helps equally or even more than jump FI. And I'm completely fine with what you have in the comment there as a pattern.
Yeah, I think
But
my
that only
initial
works with the stack validation relaxation. Otherwise, it can only happen in very few cases in comparison.
Yeah, so I mean, my initial take was to do the relaxation on the validation, and then, you know, at some point jump if I was suggested, but and I think that kind of, I think, like we've been saying, it kind of solves the problem, but the stack validation is kind of, I think it's more elegant from the compiler perspective.
That a workable conclusion for the rest?
Yeah, I would agree. From my perspective, it's also a more elegant solution. Jumpify feels like a hack, like it's something that solves one specific use case for compilers. But I see that, I understand that you ideally want both stack height relaxation and to keep jump F because it's also useful for deduplicating it across functions.
Yeah, jumpif is very important in that sense.
Hang on, if we have the stack validation relaxation, do we still need jump F?
Yeah, that's one of the questions.
I mean, you just had it in the pattern replacing jump fi, so I would say yes.
But you could use callf there.
What is the latest restrictions on stack heights and stuff for callf and all that? Does that work in all cases? And then you need callf, redf potentially. I mean, jumpf is nice in any case.
Yeah, you would need callf and redf to make it not fall off the code section without jumpf.
Oh, because you can't terminate.
Yeah.
I mean, I was under the impression that jumpf and stack height validation relaxation together is an option, and I would choose that option. So you're saying that if we go for stack height validation relaxation, jumpf would be too much on top of that?
It's not, yeah, it's just my view that I don't like jumpf complications by itself. It makes stack validation tricky around it with the non-returning functions. It's a bit messy, the spec of jumpf, I would say. And ideally, if we could get rid of it, that would be really nice. But I guess if it's really useful, then I don't know. We can keep it, I guess. It's hard to evaluate the entirety of complexity of the spec at this point. It's just enormous in any case, to me it seems.
Yeah, I'm also not entirely sure out of my head now whether the stack height validation without jumpf would still be fine. I remember that I had a lot of good reasons for asking for jumpf in the last version, but yeah, I need to revisit that. But in any case, it seems like the relaxed relaxed stack height validation is generally agreed upon as a nice solution. So that's something to target anyways. And then jumpf and jumpfi potentially wait. They can still be introduced. I guess.
Yeah, I'm not sure if jump if is still needed actually. I'm looking at the stack validation rules and it's like I think it takes some time to think through because there's the no returning case versus the non-returning case, for the returning versus non-returning cases.
Yeah, I'd also need to think it through, but we can say that with the relaxed stack height validation, yeah, jump fi is unnecessary, definitely, and jump f may be unnecessary, which in general seems to point towards going for the relaxed stack height validation.
Yeah, I agree.
I think that's as far as we'd get in this call about that.
Yeah, I think I'm fine with this conclusion. So we include both relaxed stack validation and jump F, but not jump Fi. That's the tentative direction.
Yeah, and jump F we can still evaluate whether we can actually drop or not.
Yeah, agreed.
Maybe let's try to move to the swap N stuff.
Yeah, that's fine by me.
Yeah, I'm not sure how to do that. I mean, do you see my point that it's very two orthogonal things we're addressing there? And I mean, I
Yeah,
see that for you it's more important the one thing, and for us.
I was saying, oh yeah, I think I said on the last call that it's probably easiest just to have both instructions. I mean, they're both, I mean, there's like actually obviously quite a lot of variants of, you know, swap stack manipulation instructions, which are useful. But I think for our use cases, I think that just having both swap in and exchange is the easiest thing to do.
If that's fine in sense of opcode space, that's definitely the best solution. I mean, we really need swap n. If we get swap n, I mean, exchange is nice to have. We don't need that, but I would also be happy to have it. So I guess for you, it's rather the opposite, but.
Yeah, it's the opposite. I mean, kind of for us, it's easier to spill to memory than,
Yeah.
and then, you know, stack scheduling is a little bit like intractable unless you have, you know, this exchange opcode. Because I mean, in the general case, because you can never guarantee that things are going to line up, are going to end up on the stack in the order that you want.
I mean, intractable is, yeah, the question. I mean, it's still like, I mean, you can still emulate exchange with 3 opcodes. I mean, that's annoying, but it works. Whereas swap n you can't emulate. But yeah, I mean, exchange is a nice thing, and I mean, any mathematical treatment of permutations assumes an exchange operation. It's much easier to build algorithms around it. It's not as efficient since you always, for the case that you produce something on stack top, which is a common case because you always produce everything on stack top. But yeah, I mean, I would say for that the best conclusion would be just to keep EIP 663 as is and create a new one for exchange.
I think the best outcome is to add it to the EIP 663. Otherwise, we have too many EIPs floating around.
I mean, fine either way. I mean, yeah, as I said, I really need swap n around. That simplifies our compiler complexity by extreme amounts. I mean, yeah, spilling from memory for us is a nightmare if you have dynamic types in memory, but yeah. Question is whether there's any objections from clients and whatnot to introduce 3 opcodes in that EIP instead of 2. But
Yeah, the feedback I got and the reason I replaced the opcode in the pull request is because the feedback I got was like opcode space extremely limited, and so we need to like choose exactly one opcode.
I mean, we just save jump fi, so that's one good, maybe.
Right, and maybe jump f.
Yeah, not sure what more to discuss. I mean, for us, any solution that preserves swap n is fine. That's about it.
So I think the question is like, is it okay to add an opcode slot?
For one of the exchange or 2 of the exchanges? The single
Um,
byte or the 2 byte immediate, or both?
At least the single byte immediate.
That should be fine. I mean, we're gonna have to probably spill out of the E block anyway.
I mean, if we have like a budget for swap opcodes, I can like prioritize which one. We can like start adding until we fill up the budgeted space. Because there's always, like I said, there's always more stack manipulation instructions which are useful.
But yeah, I mean, a single byte exchange version sounds reasonable. I mean, the 2 byte one could be emulated by a lot of swap n instructions then, which is not nice but workable. So
Yes,
yeah.
and usually you don't end up with that kind of stuff too deep in the stack.
Yeah, well, sure, I'd agree to that, but it's fine.
Yeah, and like you said, you can do a 3 instruction thing. So it's
What if
more
we did-
expensive. Things are more deep in the stack.
What if we did the 2 byte instruction first? Because we can always add a 1 byte instruction later. And adding the 2 byte instruction gives us the coverage, and the 1 byte would just be size reduction that we could quantify.
Let me think about that.
Yeah, I mean, I'd leave that up to Charles, but I mean, the disadvantage is, of course, that code size increases. And if you want to use exchange a lot, that's a significant effect, I would say. If a lot of that is in small stack depth, and you still need 2 bytes, but
So it would save 1 byte, do a swap 5 and a swap 3 that gets you back to, get an effective 5 and 3 swap. You would do a swap 5-3, that would save 1 byte from the 2 if you're doing the swaps a lot.
Yeah, and this is an extremely common operation. So it's like 2 versus 3 bytes. It's a big difference.
yeah, okay, true. That actually, in that sense, even already saves. I mean, for us, it's not that common actually, but yeah, either way, fine with me.
Actually, be a 3 byte swap because you'd have to swap 5 to 1, 1 to 3, and then do a 1 to 5 swap back to put 1 back where it was. So the exchange 1 or 2 byte version saves no matter how we would consider it.
Yeah, it saves 2 instructions, but not necessarily on code size. So there's
2
both
instructions, 1
gas
byte.
and code size instructions.
It would save 3 or 4 bytes per.
Not necessarily, because like swap 5, swap 3, swap 5 is 3 bytes and 9 gas, whereas exchange with 1 byte immediate is 3 gas and 2 bytes, but exchange with 2 byte immediate is 3 bytes and 3 gas.
But you would need the third swap to restore the #1 position on the stack.
Yeah, that's still 3 bytes.
It's 3 swaps versus 1 exchange.
The exchange is 2 or 3 bytes, depending on how many immediates.
Yeah, it's 1 instruction and 2 or 3 bytes, depending on the number of immediates. So we're talking both about bytes and number of instructions.
In any case, I mean, I'd myself find an exchange with 2 immediates that then covers the entire space nicer for us, because we're more likely into running into deep stack. But I'm also fine if Viper says they don't run into deep stack and want to save even more, even another byte in it. That would be also fine.
The issue is usually you want to do exchange at like the worst case, you are kind of trying to do exchange at the last step before executing an instruction. And by definition, those things aren't going to be, I mean, the largest instruction is probably like call, which I think has 7 arguments on the stack. So like you can always like kind of preemptively schedule something really deep in the stack, but I think you kind of get, yeah, maybe I can think about this more, but I think that mostly you're trying to reorder things in the stack that are kind of close to the top.
I mean, for us, things work differently, and we schedule within blocks 2 optimal stack locations. As that before the actual instruction, we don't need to shuffle anything. Though for us, shuffling only it takes place in inter-block scheduling across jumps, and there it's the entire space. But yeah, that's different implementations in the end.
So even if it's a wash with 3 swap instructions, 1 byte, and a 2 byte exchange, that's 1 opcode and it saves 6 gas, and it's in the EVM loops. It's 2 less trips through the loop, which I think the trip through the loop is probably a bit higher cost than parsing the immediates. So implementation wise, it is faster, even if it is a wash on byte size. And it's a gas savings to end users.
Yep.
Yeah, I mean, I think I'm leaning towards the 1 byte immediate.
So 1 byte exchange and a 1 byte swap that goes deep.
Yes, exactly.
Can live with that.
So I wonder if we should make exchange a separate EIP then. The argument is there's too many EIPs, but when you look at the unified spec, I think we can demonstrate that's as much of a red herring as we're doing these separations to be able to package it up in different, finely grained specifications of the very specific thing. So I don't think too many EIPs is necessarily, I think it's something that can be defended against and argued against. People try and bring, there's too many EIPs, but we can point them to a unified mega spec that is actually shorter than the merge spec and shorter than the Verkle tree spec. So I think I'm not as concerned about that. That is a legitimate concern, but I think that's one that can be mitigated.
One concern I have about multiple EIPs is that they won't go in together. So like it is more likely that one will be slashed from the final spec.
And unfortunately, I think that's the horse trading we're going to be in a couple weeks. If we can't trade horses, it just might not happen.
I mean, I would say conceptually, it's really two quite different things that solve quite different problems. So conceptually, I would say it would make sense to make it separate EIPs, but it doesn't matter to me at all. I mean, fine either way.
I think they actually make sense to go together because they're both like new stack. They're all just stack manipulation instructions with immediates. Because like the new swap and dupe instructions aren't even like unlimited. They only address 256 slots. So they're really just new ways of manipulating the stack.
In that sense, that's the common ground. Yeah.
Yeah, initially they were unlimited, but we reduced them to a single byte immediate. Yeah, I'm fine having it the same EIP or multiple EIPs. But I guess the agreement is that we do want to keep the swap N as it was, and we introduce a new exchange. Is that correct?
Yeah, I think the agreement is that we want to have both.
Yeah. Oh well, Wiper
Yeah.
wants to have exchange and we want to have swap N, so.
Yeah, I mean, since you do have the PR open to change the existing EIP, I mean, if you want to change that to add the new instruction, I guess it would be simple to merge. That being said, what Dano mentioned that we maybe need to have some cards to trade. I mean, even if it's the same EIP, we can make that statement, right? That exchange could be moved out.
So on the subject of cards to trade, one of the breaking lines I'm thinking of is we put all of the restrictions in the first release, and we add the crazier replacement stuff like getting rid of ext code copy and replacing it with code visibility and replacing the call stuff. Do some higher level stuff in the second one. So the first one doesn't change too much other than the packaging and the things that are needed to make it useful for. I think I mentioned some of this in the ETH Magicians thread, and to make put the features that the compilers need in the first revision, and then do the higher meta changes in the second revision, which would be the code visibility and the gas visibility changes. So that's, as far as horse trading, that's what my initial offer would be if they say no to Mega. And of course, my first position is if we can get Mega, let's do Mega. I'm all in for the big change at once, but it's not my decision.
Isn't the problem with that approach, though, that that's basically what we were at last year? That didn't work. I mean, that had already most of the compiler relevant changes and all that.
Yeah, I totally agree. But now, I mean, the problem is we're getting contradictory requests from opposite sides of ACD, and we just need to get them in the room together and say, look, this coordination failure is going to kill this, and it's going to drain the moat around the EVM chain if we can't update the EVMs. So this, I think we just need to get them together and have them say, one of you has to relent on your position that it either needs to go in only once or that it needs to be in smaller bits. Otherwise, EOF is EVM is ossified, and we're losing a key moat.
There.
Assuming people show up to Istanbul to get in the same room.
Yeah, don't jinx that. Right, we only have like 5 minutes left. And there was one last topic, which would be nice to discuss. The call to changes and just open it up. Yeah, I think with call 2 that the return data is removed. Charles, you brought up some concerns that this may cause some regressions in terms of gas usage or code size in Viper. Do you want to maybe like very quickly expand on that? And I would be curious to hear Daniel's view on call 2.
Yeah, basically when you already have a buffer that is bounded that you want to have the call insert the return data into, right now you just add the output buffer as the call arguments. But with call 2, as it currently stands, you would have to do some calculation to calculate which is smaller, the allocated size of your return buffer and return data size. So you need to add extra instructions around every call 2. And return data load solves this because then you can just the ABI decode directly out of the return data buffer.
I honestly didn't have the time to review this stuff, but return data load is nice in general, if that's the question. I mean, the return buffer, yeah, it's fine from my side not to have and to have, but yeah, sorry, I'm not up to speed on the latest versions of that stuff.
Yeah, I think so maybe there are like 2 simple questions to answer here. So what call 2 is doing, I mean, it removes the gas argument, and it also removes the output data area argument, so it won't copy anything to the output. And it also returns 3 different states, success, failure, or revert. And question number 1 is, are we okay with removing the output data arguments? Or would that on its own cause some issues for solidity?
No unsolvable issues. The trade-off in cost is difficult to anticipate, but I wouldn't expect it to be bad either way. It's fine in that regard. I mean, we also do use the arguments for static return sizes, which is probably the more common case in Viper even, I would imagine. But I think the cost of always using return data copy is not bad for how we implemented things currently. Not too bad.
Okay, yeah, I think for the output area, the base argument is, unless there's going to be a strong argument for keeping it, then we probably want to just remove it in order to simplify the opcodes. So this is something to probably follow for the next few weeks. And the second question is the return data load instruction, which I guess the answer is a yes, that both compilers would love to have this instruction.
I mean, the thing to think about there is that, of course, compilers want to have all sorts of instructions all the time because it makes everything easier. But return data load is very nice. That's definitely the case.
Yeah, I think the issue here kind of is like if call 2 is going to force us to use the return data buffer, then the feature set should be on par with memory. Because like previously we could use memory and now we can't. So we need to have return data load.
Here comes like a difficult question regarding return data load on the semantics. So return data copy currently aborts if you go out of bounds. But mload and call data load just return zeros. So what would be the semantics of return data load? Would it be padding with zeros, or would it abort?
Can we please change the semantics of return data copy to not revert in the first place? That would be ideal. And then also do that for return data load. Just make it exactly behave like call data copy and call data load.
Yeah, the only issue with I'm okay with either. The only issue with return data load reverting, if it gets too many bytes, is that if somebody ever wants to return packed data, like 1 byte of data, then you have no way of accessing that with return data load, which is less of a problem actually than call data load. So like call data load, there's more incentive to pack it, but return data load is priced so that there's no incentive really to not pad with zeros. I mean, from the returner side. So there could just be a convention that return data is always at least 32 bytes.
General, the divergence between behavior in call data copy and return data copy is quite horrible in general, I would still argue. So, I mean, I would love to see that unified, and I would, if I had a choice, unify it and not reverting and zero padding. But
one nice thing about return data reverting is that it simplifies ABI decoding checks. So when you're doing ABI decoding, you can just rely on the return data reverting on out of bounds, and you don't have to do them manually.
So if we got rid of the revert on return data copy, would Solidity and Viper need to write 2 separate subroutines to handle the new revert-free logic, or would it just be, if we're in the reverting logic, here's some extra steps, otherwise skip these steps?
I'm not quite sure I understood, but I mean, we never rely on return data copy reverting. We just have to avoid running into it. So for us, it's a pure simplification to not have it revert.
Right. So the code that you would write that would make sure it doesn't revert and do the verification, you would just turn that code off when you're generating EOF. You wouldn't have to write different code to replace it. You would just not generate it.
Basically.
Yeah, for Viper, that's the case. So like whenever you do ABI decoding, there's some checks, like that it's a certain size and so on, and you would just skip those checks if the return data is reverting. If it's not reverting, then you just add those checks the same as you do for call data.
Okay, that makes me more comfortable, because if we were going to have to write 2 separate sections of code, whether it was EOF or a legacy, then it brings a security complexity risk. But if we're literally just turning a code section off when we're in EOF, that's the same surface mostly.
We might have to maintain 2 different code paths depending on the output target.
And that's the concern, is maybe increasing the surface. But if the returns are big enough, then it might be worth the risk.
Yeah, let me think about that. I actually haven't considered what would happen if return data is not reverting. So it might be this. We might be able to get it to be like basically the same code in either case. I'm not sure.
I think the ideal would be that the difference between legacy and EOF code is, here's some code that checks for revert and it's just absent. But I'll let your compiler guys make the best decision there.
I mean, for us, it's not a problem. We could live with the change either way and have unified code. If I'm not misremembering that wrap extremely at the moment, I think we basically avoid the situation from happening anyways.
Like, oh, I see. I mean, Daniel, if you're asking, do we depend on return data reverting right now? The answer is no.
Right. So that's fine.
We don't depend on it now, and we might be able to depend on it in the future with call 2, but otherwise we would maintain the same code path.
Yeah, the big upside is whenever there's a Solidity tricks and troubles API conference talk, they always mention this. So this would be nice to get this off their list.
Yeah, I wanted to mention one last thing. You know, I mean, we're like 6 minutes over the allotted time frame. I'm not sure how much time people have. But in 2 weeks, when we would have the next EOF call, we have DevConnect, and I think most of us are going to be in Istanbul. And I think, in fact, 2 weeks exactly from now is going to be the EVM Summit Day. So I wonder if you could maybe allocate some time to meet up there and maybe discuss some of these points more in depth. Or should we consider getting some in-person meeting if most of us are going to be there? Or otherwise just probably set up the next EOF call to be the week after DevConnect.
I'll be there Sunday through Thursday, Monday through Thursday at least. Debating whether to trim my travels or keep it, but those core days I'll be there.
I'm still deciding whether to go, but it would be Friday through Friday, and I could meet for the EOF stuff.
I'll be there. Also be at the EVM Summit.
Okay, so probably skip the next one and pick back up 1 month from now. Skip the next call, but meet in DevConnect sometime.
If there's a meeting being planned at DevConnect, it might be good to have it be like dual attendance, so people can attend remotely if they want.
Yeah, sounds good. I mean, yeah, let us know if you're not going to make it, then we can accommodate you. Or if there was someone else that said so.
Right. Yeah, I think we made really good progress today in closing out these last questions. Hopefully we can close them out during that meeting. But Daniel, you mentioned that, we may want to think about how to actually deliver this and how to split it up if there's, more pushback on some aspects. So what do you think? What regarding? I mean, we proposed this for Prague. So what kind of timelines are we looking forwards to in terms of like ACD discussions? Do you think, assuming we make like most of the decisions during DevConnect, then probably we can implement those in the specs like in a week or two after? When are we going to bring this up on all core devs again?
So I was hoping that we would be able to have more all core devs meeting together in Istanbul, but looks like some people may not be there. I think we should try and have these talks in parallel in Istanbul if we can pull them off, if we can get the right people in the same room. Otherwise, because I think we need to get a clear signal from the people who are raising the objections as to whether a two-step solution would work, or if they just object to EOF in principle. And I'm secretly concerned that there are people who just object to EOF in principle and want to see the current EVM frozen, and that's the biggest concern. But if they're just concerned about the size, and another concern that was brought up in Bogota was we don't want multiple versions of EOF live. But I'm thinking, this goes into my thread that I was posting on Ethereum Magicians. If there are still two versions, but they only differ in opcode set available, if all of the validation is exactly the same, it's just a function of which opcodes we push into the opcode validation loop, then I think it's easier to say that, to have three different instruction sets available, legacy EOF1 and EOF2, if that's what's going to take, and have EOF2 be the main recommended one. But the EOF1 just doesn't have the visibility, the observability stuff removed, and we just change which opcodes we put in. We put all of the restrictions in EOF v1 and v2, and we use the same validation core logic to verify them. That's what I think the two most viable approaches are. And of course, my favorite one is just to do everything at one time and see what the concerns are and see if we can address their complexity concerns. If the issue is just about testing, if the issue is about utility, if whatever their issues are, make sure that we can get them and make sure that the objections just are, I don't like this and don't want to see it done. If there's technical issues, if we can address them. If the issue is it's too large, I mean, it's sometimes that's intractable, but that's what I would want to see, is if we can gather this together while we're in Istanbul But I don't think we should go back to all core devs before, the second call in January with this, unless we have a concrete plan that everyone's on board with. I think we need probably after they split establish the Goerli fork, so we could do it in between the Goerli and whatever the next fork would be. But I'm open to negotiate. I'm open to other alternative ideas. I'm not, it's not that plan or nothing, but that's, an initial plan to go with.
All right. Yeah, I mean, let's see what we end up doing at DevConnect. I think the only question I had left, whether we should tentatively schedule the online call the week after DevConnect, or as Matt said, 2 weeks after. Yeah, and I think I'm tentatively leaning towards the week after DevConnect. Just so we can get but that would be out of cadence. Yeah, I guess we can do it like 1 month from now, and then let's hope that we
cadence would be the
Very good.
29th. DevConnect would be the 15th. So for the fifth Wednesday in November, we got 5 Wednesdays.
I mean, it's 2 weeks from now, and we have it every 2 weeks, so like 4 weeks from now.
Yeah.
Would be the ideal one.
I like that idea. Keep it in cadence.
Right. Awesome. Yeah, we went slightly over, but I think this was super useful. I'm not sure, Matt, you're the moderator. Do you have any closing instructions to say?
No, great call. Thanks a lot for the discussion. Appreciate you being on here also, Daniel. It's pretty helpful sometimes to just sit down synchronously and discuss these things. Hopefully I'll see a lot of you guys at DevConnect. Safe travels, and we'll pick this call back up in the near future.
Thanks. See you guys.
Bye.
Thank you.
Thanks.
Bye-bye.
Bye.